Hi class, let us talk about aromatic reaction and in particular reactions involving benzene. Benzene with a formula of C6H6 has 8 fewer hydrogens than the corresponding 6-carbon alkane hexane and is clearly unsaturated, usually being represented by a 6-membered ring with alternating double and single bonds. Yet, it has been known since the mid-1800s that benzene is much less reactive than typical alkenes and fail to undergo typical alkene addition reactions. Cyclohexene, for instance, reacts rapidly with Br2 and gives the addition product 1,2-dibromocyclohexane, but benzene reacts only slowly with Br2 and gives the substitution product C6H5Br. Let us first learn some terminology that is degree of unsaturation. As mentioned earlier, benzene has 8 fewer hydrogens than the corresponding 6-carbon alkane. So what do we mean by degree of unsaturation? Okay, so this structure is saturated, 0 degrees of unsaturation. Likewise, CCl4. But whenever you have a ring, it has 2 fewer hydrogens than its counterpart, alkane counterpart, yung open chain. So it has 1 degree of unsaturation. When you have a double bond, that is another 1 degree of unsaturation. In the case of benzene, meron na siyang ring at meron pa siyang tatlong double bonds, and so 4 degrees of unsaturation. Okay, because it says here in this slide, benzene has 4 degrees of unsaturation, but undergoes none of the common reactions of alkenes. So with HCl, normally sa alkene, merong reaction, addition reaction, but with benzene, no reaction. Br2 and CCl4, with benzene, no reaction. Hydrogenation in the presence of a catalyst platinum, very slow reaction. So clearly, benzene does not behave like alkene. Okay, so these are the reactions of benzene: halogenation, nitration, sulfonation, alkylation, and acylation. I don't have any more to mention the conditions. Nasa inyong book yon. Okay, so these are called electrophilic substitution, aromatic electrophilic substitution reaction. Okay, uh, this is in page 166 of your textbook. The, the section is entitled Substituent Effects in Electrophilic Aromatic Substitution. Okay, if you are dealing with benzene, only one product can be formed. Okay, when an electrophilic substitution occurs on benzene. But what would happen if we were to carry out the electrophilic substitution on a ring that already has a substituent? A substituent already present on the ring has 2 effects. Okay, so the first one is reactivity. Okay, substituent effects on reactivity of an aromatic ring. Okay, some substituents activate a ring, making it more reactive than benzene. Okay, so take note, our point of reference is benzene. And some deactivate a ring, making it less reactive than benzene. In aromatic nitration, for instance, the presence of an OH substituent, okay, makes the ring 1,000 times more reactive than benzene, while an NO2 substituent makes the ring more than 10 million times less reactive. Okay, so dito, okay, so this is our point of reference, benzene. Kapag may OH, 1,000 times more reactive. Kapag may NO2, so this refers to nitrobenzene, less reactive. So una niyang effect is reactivity or rate of reaction. Okay, so yung susunod naman, okay, the other effect is orientation of a reaction. The three possible disubstituted products, ortho, meta, and para, are usually not formed in equal amounts. Instead, the nature of the substituents already present on the ring determines the position of the second substitution. An OH group directs further substitution towards the ortho and para position. Okay, what do we mean by ortho? So if this is the OH group, this position is ortho and this position is para. So an OH group is an ortho-para director. Okay. While a CN, cyano group, directs further substitution primarily towards the meta position. Okay, so this is the substituent, the cyano group or the nitrile group. Okay, nitration would uh, direct the nitro group meta position. Okay? Again, ano yung mga position? This is ortho. Okay? Etong position na to para and this position is meta. Okay, so this is also a figure that you have in your book. This shows you the effects of the various substituents. Okay, so ito yung mga meta-directing, they are called deactivators. Ito naman, ortho and para-directing deactivators. Anong ibig sabihin? Deactivators, slower than benzene. Okay, so ito yung ating point of reference, benzene. Ito ang dito, ang mga deactivating. Dito naman sa kabila, ang mga activating. So may activating or ortho-para directing. Merong deactivators, ortho-para directing. At meron namang deactivators, meta-directing. That's the end of the presentation.